Hi everyone, it's Nono here one more week, and I want to welcome you to my live stream. This is a place, as you might know already, that I reserve every week for creative coding, machine intelligence, and many other things. If you don't know who I am, I'm a computational designer, artist, former architect, and what we try to do is do hands-on coding many days. Other days we do workflow optimization. Other days we think about the projects, and other days we do things for the Getting Simple podcast, which you might have heard already. So I'm gonna get started, and we'll talk a bit more about what we're gonna do specifically today in a second. I'll encourage you to like this video if you want to support the work that I'm doing with the channel, and to follow me and subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. During this live stream, you can type any words on the chat and I'll be looking at it here on my left. Also tell me if you can hear me and see me okay, and maybe where you're connecting from and what you're looking for learning, why you came up with this, or how you found this live stream and why. Also, you can join us on the Discord server. So this is a community online that we have on Discord. You can use the QR code up there, or just go to nono.mas/Discord. And this is up out of date. Okay, I forgot to update this slide. Last week we took a look at. I'm gonna show in a second at what we saw last week, and you can submit questions at gettingsimple.com/ask. And today, we're gonna take a look at the pixel to style to pixel training, why it didn't work, and take a look at how to encode in style, right? How to have our own model to encode images in a latent space of a StyleGAN pre-trained model. If you don't know what these things are, we've been covering this topic in the past 4 or 5 live streams already. And what we have here on screen is a recap. So in live 54, that was last week, we took a look at the PSP framework. As I mentioned, I show a recap on the pixel to style to pixel training runs that I've done offline and on the live stream. I do a walkthrough on a sketch simplification notebook that we built, which is using an open source repository to simplify sketches. But actually what we do in that live stream is go from real images into something that is an outline drawing or something that could look like a hand sketch on a tablet, because we're trying to build a data set to train pixel to style to pixel. We forked PSP and customized the generate sketch data .py script, which uses specifically that library that I was mentioning before for sketch simplification. We also looked at how to create a command line application on Python. So we did that, making the script accept arguments, something that you might want to learn if you want to revisit that. And we didn't have time to prepare the dataset, but we saw some keys of how we would go about it. Today, I had an idea here on forking pixel to style to pixel and customizing it for training, so we don't at least make a branch that is customized for our needs, so we can clone that from Google Colab without having to change things scripting or manually. And also I wanted to take a look at this. So there's this part here where it says dataset type FFHQ encode, which I have here a note to check if this is not the error that we were seeing during my training runs. I'm not sure. I would just want to take a look. It might not have anything to do. I think this just sets the transformers and how the dataset is processed. But we'll take a look, because there is another dataset type that is a sketch to image or something like that. Okay, so let's get started. I'm going to record an intro as always, just in case we edit later this video. Hi everyone, it's Nono here, and this is one more working session of the Intelligence and Sketching playlist. Today, specifically, we're going to continue taking a look at the PSP framework, or pixel to style to pixel. We're trying to build a dataset to train. We already have a notebook built that we've done in previous videos. And don't forget to join the community if you want to share your work or ask any questions at nono.mas/Discord. You'll find an invite to our Discord server. All right, And we're gonna see. I mean, I'm not sure how much I'm gonna show today because we've seen this through this recap on live 54, so we should have another video that covers this. Long story short, we have a StyleGAN model that knows how to generate images of daisies, and we'd like for it to be able to do this task, right? So we have simplified or converted these input images into simplified images that look like sketches. We want to go the other way around and try to bring that simplified image into an input so we can draw new flowers and get the texture. This is something that we were doing many years ago with Pixel, so Pix2Pix, but we're trying to do it now with this network. All right. So let's see what else we have here. And as a reminder, we're trying to encode, so do StyleGAN inversion, where we input something, get a latent vector, and then we get that into StyleGAN. And here are some of the tests that we did on last live stream with different parameters. So we added command line arguments to this generate sketch data script, and we can generate a data set like this easily. So maybe that's something that we do today. And I, just for fun, I passed my sketches through this neural network and obtained these results. If the lines are too thick or you have watercolors, the results are not great, but we're getting something, and this is sort of out of the box. We don't have to do anything because the algorithm already does it for us. Okay, so I guess we just need to get started with coding and taking a look at these things. Please give me the thumbs up on the chat if you can hear me and you can see me okay and everything's working fine. All right, so I'm gonna minimize this now. I'm going to close this one here, and I'm gonna take a look at the folder 55 to show you what I have. So this is a data set which I've built, which has these test images, right? So these are images that I use to train Pix2Pix that surprisingly works well. And these are the target images that we're aiming at getting, right? And we have a test set and a train set. We can see how many of each we have if we open this, right? So we have 500 train images and 128 test images. And the idea is to replace these images here with something that looks more like what we saw on the previous video. So on the slides, more simplified, because these, I think there is too much noise maybe here for PSP to know what it has to do. If we see this slide that I put here today, I'm going to check what this line is doing. So the FFHQ encode line. And the first thing I'm going to do, I'm going to go to Google Colab. And in Colab, we're going to revisit the notebooks that we built in our last live stream. So we can see here a listing. So let me actually close things to make this a bit faster, at least on my end. Oh, and let me actually also stop Dropbox. Well, Sajeh, thanks for connecting live. I see your message on the chat. It says, hello chat, Merry Christmas and Happy New Year to you all and your loved ones. Thanks, Sajeh, for being there for the entire 2021. thanks everyone else who's been contributing on the community and also on the live stream. You know, it's impressive the amount of contributions that you guys have done and how much it helps me keep going. Okay, so let me, now that we're here, let me take a quick look at this camera. Okay, so we also have this camera here available as in the last live stream. So I'm just testing out things, as you already know. And yeah, so let's keep going. So I have my desktop here, and what else is there? Okay, so nothing is there. All right, so I was opening here this okay, let's see how much battery we have. Okay, since we have battery. All right, so let me go back to Colab because we missed that panel that lists all of the available notebooks that we have from the past. So Live 53. I don't know where this one is. Okay, December 16th. So we have these two. So, all right. Yeah, and we predicted with the ACES model. So this is the sketch simplification notebook. So we could run the entire data set through here. Maybe that's the first thing that we need to do today. And let me see, how can I have here my chat and the stats together? Okay, so stream seems to be healthy. My computer is gonna be slow today. I'm not sure why. Okay, so we're gonna open this one. All right, so let's browse through this notebook that that we've built over the past live stream. So here I'm doing a lot of scripting, and we're going to not do that by configuring where our dataset lives directly on our own repo, right? So we're gonna clone that. And what I wanted to take a look at today is these options. We have it right in here. So dataset type FFH encode. And let's actually go. So sketch simplification, we're gonna close it so we don't have too many things open. Okay, so we're gonna go to the big SPI framework repository. And also, Merry Christmas to Mayer. He's also here in the chat with us. Thanks, Mayer. You've also been a great contributor this year, and you've also contributed to the community with a lot of content, which, it's hard to catch up with so many videos and interviews that you put up there. And yeah, congrats. And I'm looking forward to catching up also with your new ArchiDAO project that sounds super interesting. Okay, so let me see if that is here. So is that ArchiDAO? I don't know what handle you have on Twitter. Yeah, okay, Archi_DAO. That's how you can find Mayer's project. And Yeah, okay. I'll pass it somehow on Discord. Okay, so yeah, and you can see there is a lot going on here, so looking forward to learning more. Okay, so let's see. Okay, so yeah, we can, and I guess I don't know if you saw, but Jose Luis did a on Parametric Camp. He did a community call last week where I also joined for a brief amount of time, and so let me see if we can put it here. So I would love to do one with you guys, with everyone who wants to join on Zoom. Yep. So here it is. Parametric Camp Community Meetup 2021. Awesome. Okay, so let's continue taking a look at this. I was gonna take a look at the configs. So transforms. I think so. These are the transform types. The paths config has the paths of the datasets, and the data configs has the configuration of the dataset, right? What we're gonna train with. And I believe yeah, so I need to do some sort of RSVP where you guys tell me what time works better, right? Like what time of the day, what day of the week, and things like this. I'm on vacation at the moment, so I have a lot of flexibility, let's say. Okay, so this is datasets FFH encode. So dataset type FFHQ encode. So it might be just this, and we probably set that in live 53. So this is our data configs where we were, okay, so we were setting flowers sketch to daisies. Flowers sketch to daisies. Yeah, so I'm not sure. I mean, let's see what name this has. Okay, let's see. Okay, so I might have done this on a different account. So let me look at that quickly. Okay, let's see if this is it. We still have FFH encode. I'm unsure now. I don't know where I've put the latest. Okay, I have another one here. Hello, Bea. Nice to see you online. Hola. And okay, so let's see what data set we're using here. Okay, so here we were using it properly. So flowers sketch to daisies. And gradual styling coder. So let's take a look from their page. So from the main repo. So we're gonna close this one. So I guess this one is v4 offline. Maybe we call this v5 so we don't confuse things. And I'm gonna save yet another copy so we make sure that we have a specific notebook for this, for today's live stream. Okay, so this is gonna be this version 6 and it's gonna be live 55. Okay, and I guess we've been going with this for a long time now. Okay, great, cool, awesome. So let me see the training, the PSP encoder, frontalization, sketch to face. Okay, so here they have celebs sketch to face. That's the data. Let's see, path. So if we take a look at this experiment, celebs sketch to face, they have that here. So that's celebs sketch to face. They have a sketch to image transforms, and they have the celeb train sketch, celeb train, celeb test sketch, celeb test. And what we had was source and target. So input and target is like the train and sketch. And on their paths config, select test sketch, train sketch, select train and train sketch. So that would be source root is train sketch. And target is train. So sketch is the source root. Source root is the sketch, which for us source was input, that was our sketch, and target was our target. And we had that in data configs. So in data configs, sketch to image transforms, flower sketch to daisies, and source root, we had train source and train target. Train source will have train input. Okay, so this config for us seems to be good. So what I'm gonna do is what I said before. We're going to clone the repo. Well, I'm basically, I have a fork already, so I can go there, I think. Awesome. So we're gonna go and start. So this is my own fork, and one commit behind. Okay, what is the latest commit that they've done? All right, so let's clone it and let's start with it. Okay, so git clone pixel to style to pixel. So I'm running this on the desktop. And the first thing we need to do is we're just gonna sync. So we make sure that we have the latest synchronized. All right, so we access pixel to style to pixel, and we remote add, we're gonna call it upstream, and we're gonna do add this thing. So we can do now git pull upstream master. You'll see that we'll get the diff for, you know, the file that has been edited, readme, and then we can push to our branch. So you're gonna see that now we're gonna be up to date, right? So you can see that in here, this branch is up to date. Cool. So I don't have any, well, they have these branches, and I think I did this one. Okay, so let's do git fetch origin sketch simplification, because we could do a PR to contribute simplification. Simplification. Okay, so here we have one commit behind, so we're gonna update, and now we don't have any commits behind. All right, so we have our sketch simplification branch, and what we want to do is create a different branch, and it doesn't actually need to be the same branch. So I'm gonna go back to master, and I'm gonna create a new branch that is gonna be called sketch to daisy. Maybe sketch. That's shorter. All right, so now we have the branch. We can push it with git push origin sketch. Now we're gonna have that branch here as well. So we pushed it to the internet, right? And it's gonna be up to date with master. And now from here, I'm gonna open this on Visual Studio Code, and we can start from here. So this is gonna allow us to edit things here and have them be permanent, let's say, when we clone them in the repo. Okay, so I'm gonna get the data configs and the path configs that we did last time. We don't need to redo that. So I'm gonna get this flowers sketch to daisies in here. So we're gonna add this, and we can format this properly. Okay, and maybe we can even rename these things a bit, but because I like this better. So train sketch and train, that's probably better in terms of the paths. But yeah, let's get this first and close this one, and we're gonna open the paths config now and paste our new data sets. Right, so here what we're trying to do is sketch to daisies, right? So maybe we put here sketch to daisies train sketch, right? Is that how the other one is set? Dataset paths celeb a train sketch. So it will be daisies train sketch, and then here we can have daisies train. Maybe we just do this. And then here we put sketch. And actually we could do the same here. And train sketch, train photo. Yeah, maybe, maybe that's easier to understand. And data, PSP data set, train sketch. So train photo, train sketch, test photo, test sketch. Okay, and in dataset configs, now we have this config here, and all we need to do is just refer to those. So source target, so the source would be train sketch, test sketch, and then I guess this works. Yeah, so, oh, no, it doesn't work. So it would be here, 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 here. Okay, I guess we just need to move this. Okay, so let's recap on here. So we have, okay, we have the flowers sketch to daisies dataset. And maybe we don't even need the flowers part. So sketch to daisies. This is celebs sketch to face. Well, maybe, yeah, flowers sketch to daisies. So we have flowers sketch to daisies. And we have the transforms, which is, oh, actually that was right. So we had this right before. We want the source to be the sketch and the target to be the train photo. The source to be the sketch and the target to be the test photo. Okay, so this now looks good to me. I hope this makes sense for everyone. So we have flowers sketch to daisies, and here we have the sketch, train, sketch, train. This is input and output, input and output. Okay, so we have this here, and this should be enough for having the algorithm understand what we're trying to do. And yeah, so we're gonna do now git add all, git commit, what are we gonna commit? Add sketch to daisies dataset config. Okay, so we do that, we do git push origin sketch, and this is now going to synchronize it with our branch. So you can see here that we're now one commit ahead of the original repo. You can see my commit here, and if we click on that commit, you can see the diff, what we've added, right? So I've added this part here to the datasets and this part here to the configs. One thing to note that we have on our code already is if I close these two, so this is flowers sketch to daisies, if I look at the data, right, these flowers sketch to daisies, the dataset, is using a transforms config that is called sketch to image transforms. And if we look in here, so in configs, okay, there is some lag in here. I'm not sure why we're having issues today. Okay, let me see. Okay, seems like it's stable now. All right, so let's continue. So we have these transforms here, and what I was mentioning is that we have these classes, right? And the one that we're using is a sketch to image transforms. And what this does is that it resizes the image to 256 to train, ground truth, train, source, test, inference. I don't know, I don't see anything that shouldn't work here. Well, okay, so let's keep going. So that seems good. And so now with this, we need to go back to our, so let's close Visual Studio Code for a bit. And we just need to go back to our repo. And now instead of cloning the original repository, which was in here, we're gonna clone mine, and we're gonna clone the branch sketch. And just to verify temporarily, we're gonna see the contents of content pixel to style to pixel, and okay, we have this here. So we'll be looking at the contents of config, for example, paths config. And data configs. Okay, so first thing, we're gonna just run these things. Let's just remove this. Yeah, let's just remove that, and let's see if this data set still exists somewhere on. Oh, the item was deleted. Okay, yeah, I did delete the data set, which is gonna be a problem now that I think about it. I did delete the data set from Dropbox. Let me see if I can recover that on Dropbox. We'll probably have to get a different link, but I might be able to get it back quickly. And also, I'll take a chance for if there's anyone new that just connected. Feel free to say hi on the chat and let us know where you're connecting from. And also, Merry Christmas. I hope you have a great vacation if you have holidays. All right, so I do have here the data set, which I'm gonna restore. Let me see what is easier. Okay, so I'm gonna restore the files on Dropbox. I do have though the data set here, so I copied it in here today, And the idea is that what I showed before, we rename to match the contents of the files that we need to see there. So let's just run this. So let's ensure that we have the good, all right? And we're gonna connect to a runtime there. And we're gonna execute these cells. So this one, we're gonna install Ninja, and then we're gonna clone this repository, the sketch branch. Yeah, let's see if we can. Okay, cat is not defined. All right, my bad. Missing that bang. So it's gonna tell us that we already have that there. We're just gonna see, and as you can see, we do get the configured files there and here. So we have the dataset here as well, and that is because we're cloning the branch from my fork, not the original repo, so we can change it and modify it there. Awesome. So we're gonna remove this code because we don't really need it anymore. And I guess we're gonna mount Google Drive. We don't need to do this anymore. I'm sad to see this go because we spent some time doing this, but it's okay. And this is to download the pre-trained models. This is StyleGAN to download pre-trained FFHQ model. We don't need this because we are going to be using our own. Let me clear all outputs. PSP dataset from Dropbox. This is what we need to download, and all right, and we need the StyleGAN model here. Okay, so checkpoint path, we're not going to use checkpoints, even though we could, because I already was training for a bit. And this is our parameter here, so let's put this here. Okay, let's verify that this exists, so we can go to terminal. Well, it's not gonna exist because we haven't mounted the disk. I'm gonna mount it right now. All right, so our drive is mounted, and we should be able to go here and list the contents. All right, so we are talking about this one, I think. I'm not sure if I can open things here. Okay, so let's actually copy this image. So I'm copying the image from Google Drive to here so we can open it directly into here. Okay, so I don't think it makes that much sense to train with the dataset that we had last day because it didn't work. So I think it's worth for us to go and try to create a new dataset from scratch, as I was showing on the slides, and see. So this image seems too big, so we might not want to download it or open it here, but it's okay. Okay, so we've mounted the drive, we've cloned the repo, we have to download the IRSE50 model here, which seems like it's downloaded now. We want to download this our PSP dataset, and how are we gonna do that? I mean, we have the dataset and we can try to use it just to see what happens. The first thing I'm gonna do is let's go to our config and see how we name those folders. We rename them. So paths config, and we need to name them as train sketch. So this is train and this is sketch. So okay, so basically we do replace input with sketch and output with photo, which we don't have, so target with photo. Okay, so we have the test sketch and photo and train sketch and photo. All right, cool. This dataset is not great because it has a lot of different types of images. So let's call this V1 and let's try to make a second version today. So we don't clone all of the images. We don't really care about the sketch images now because we're going to make different ones. And okay, so let's just remove it from here. And A and B. Okay, we have like a script that we did to split, so we don't really need to. Okay, maybe what we can do is maybe we need to edit to basically create the folders with the new file convention that we wanted. So we'll put here, this would be sketch and this would be photo, and I think that should be it. That should do it. Okay, so we have this name. Okay, so that's not even used. Okay, so if I run, so if I were to delete this, right, we have A and B. So A is this and this is B. If I do Python split.py, we create the data set and then we get those folders, right? So we get a split between test and photo automatically, which represents the percentage that we've set here, which would be in here 80%, right? That's kind of hard coded on the script and we could customize it. Okay, so long story short, we have the sketches here and we're gonna remove them, and here we're gonna do a hand filtering, so manual dataset creation, because I want to make sure that we have all the photos that have complete flowers that we could draw later. So I'm going to be removing all of the ones that I think are not representative of what we want. Not sure about those. There are a lot of images, but you know, it's okay. We have time. So we're now going to filter and try to make so the problem with this, right, what is problematic about this is that I trained a Stalgan model with the images that I had before, and we're gonna have to retrain the entire Stalgan model to be able to get this type of flower images. But anyhow, so this is the data set curation process, which is as manual as it can get. Yeah, these are not the type of flower that I want to generate at all. Wow, there are a lot here, so I don't know if we're gonna be able to do it. If you're watching this offline, you can put it at 2x or like skip it. I'm just removing all of the images that are not similar. What is this? All the images that basically are not representative for the task that we want to achieve. This is something I never sat down to do, and if I had, this probably would have improved the accuracy of the data set a lot. So it's good. We're here. Yeah, I guess we need a better interface for this to do the labeling. Maybe we can crowdsource this and people can help do this task. All right, get in there. Can you see the pattern of the images that I'm deleting? They basically are images that don't look like this or this, right? All of these, if they look all like that one, that'd be really good. All right. We're gonna run out of images. Sure, what type of daisies these are. Okay. So the logic behind what I'm doing is, if you wouldn't want your network to generate an image like the one you're seeing, you should delete it, because otherwise your network is going to learn about the images that you're providing it with, and then it will get confused, or you will get confused by why, for example, why is it generating an image of a cat, right? Also, another thing is, like, it seems, so this dataset is 256. It's not 1024, which, it's ideally, because that's what the Stallion model is trained at. So maybe we do have that dataset at high resolution somewhere, because I was the one who converted the dataset to that size. Let's see. If I look for, yeah, it seems like it is the same size. So yeah, we need to build a better dataset. Regardless of me doing all this filtering. Okay. We're at 339 images at the moment. Right, this is looking a lot better. Let's remove these ones. Even this. All right. Seems like we're done. Okay, so we have this data set, and what we're gonna try to do now is go to, so how big is this? Let's see what happens if I enable Dropbox while live streaming. So what I'm gonna do is I'm gonna upload this, and we're gonna try to create the data set that I mentioned before with the sketch simplification script. So we're gonna try to get all of these images into line drawings. All right, so to do this, we need to close the other session, I think, unless we stop using GPU on one of them, or I'm not sure. Okay, so because we okay, so let's see what happens here. All right. So before we get to train, I'm gonna revisit once more the recommended settings in the official paper. Start from latent average, LPeeps, sketch to face. Bat size is 8. Yeah, does the bat size influence a lot? I'm not sure. LPeeps lambda 0.8, L2 lambda 1, ID lambda 0, label NC 1, max steps 300,000 I have. Okay, so let's read a bit here. So specifying label NC0 default will directly use the RGB colors as input. What happens if not? Similarly, for generating images from sketches, please specify label NC1 and input NC1. We assume the StyleGAN used outputs images at resolution blah blah blah. If you wish to use a StyleGAN at smaller resolution, you can do so by using the flag output size 256. Options, train options. Train options. Okay, so train options, output size, encoder type, which encoder to use, dataset type, type of dataset experiment to run, batch size, for training, test batch size, workers, test workers, learning rate, default, optim name, whether to train the decoder model, false start, LPeeps, image interval, interval for logging train images during training. Board interval, interval flow matrix, tensor board, val interval, validation interval, save interval, use 1dB, resize factors. Okay, so it seems like we have that under control, and then here data path, checkpoint path, couple outputs, whether to also save input side by side. Okay. Test options. Okay, so this is probably the follow-up thing that we're gonna do is to, so let me write a note here. Next thing on PSP is to test script.generate.py and use the latent mix or mask. What is it? So options, test options, latent mask, mix alpha to do style mixing. Okay, yes. All right, so this should work. And again, what I said, we need to train a StyleGAN model and then the PSP model. One thing that we could do is try to train the sketch to face, but we don't have that data set available, I think. Okay, so we have Dropbox. I do have the data set, and we can put it in downloads. So we have this data set v2. We're gonna move it here, at least temporarily, and we just need to put all of these images inside of the well, 300 images, right? So you need to put these 318 images inside of this notebook because we're going to create a data set. Manage session resources. So what time is it in terms of, okay, so it's 1:09:30. Okay. All right, so let's take a look at how to run the sketch simplification notebook on this data set that we just added to Dropbox, which has all of these hand filtered images of daisies. So we've curated the ones that actually look like daisies with the white leaves and or petals and the inner yellow side. And if that is already uploaded to Dropbox, we should be able to go there. All right, so we have this data set, and if we get a link to this folder, we should be able to download it. All right, so this is gonna be Okay, so let's say here that this is optional, because we're gonna download a data set from Dropbox. So data set is gonna be this, and we just need to do this. Files. Okay, so let's execute. So we manage the session, so I'm gonna close the other one, and let's make sure we have a GPU runtime, all right? And let's run these things. It might take a bit. Okay, so when we have the okay, and we are cloning my branch of sketch simplification, we run that algorithm, and we have to put that in content inputs. So we're gonna make a dir that's gonna be called content inputs, and make a dir that's gonna be content outputs, and then we're going to enter content inputs. We're gonna download these files, and then we're gonna unzip them. Let's see if this works. So probably we're installing dependencies. Yeah, so we need to install specific versions of PyTorch and Torch Vision. And yeah, so let's execute everything here. So at least up to this point. And while this is being executed, let me see if I can take a quick break and we'll get going. Okay, I am here. I'm back. Cool. So let's see. Let's make a quick. Let's take a quick look at the results. Oh, Rob Beal. Hola, feliz Navidad y próspero año nuevo. Nice to see you online. Merry Christmas, Happy New Year. Thanks for connecting. Thanks for popping by. We're going to do a community call. I was talking to Majur and Suje above on the chat. We have to do it quickly, pretty soon. I don't know, maybe at the start of the year or the end of this year. And yeah, I don't know. I would love to count with Sajed, Majur, Rob, Pedro Cortés if we can find him, Juanda. I don't know if Jose Luis might be able to join, Ricardo. So, yeah, I don't know. Everyone who's been contributing on the live stream and on the community. Okay, so the contents, inputs and outputs. So we have these inputs and we have these outputs. Okay, so let's make a montage of both of these. So montage of inputs. It's gonna be called inputs. So this is, yeah, it says maybe photo, and the other one is gonna be montage dot outputs sketch. And the geometry, I guess, like if this is 256, right? So maybe for now we do this, and same for the photo. Okay, well, let's try that first and see what happens, because there are too many images, right? Yeah, there are too many images. Ha, Ricardo. Nice to see you as well. Just mentioned you. I don't know if you were there or if I I just kind of invoked you. Cool. That's nice. Yeah, you also tell me when it works better, what time of the day. I know that Sodibius cannot make it if it's this late. So maybe we need to make a poll or make some sort of options where we have one or two at different time zones. So 190 images. Why do we have 190? Didn't we have more images? 319 items, and we only have 190 outputs. There are some images that are not properly formatted, I guess. Nano, make file, montage, geometry outputs, get the JSON. So let me see, make montage. What image? Okay, so yeah, hi everyone. Okay, Alvaro, nice to see you online. Thanks. That's the best comment you could come up with. It's great. Oh man. Great. All right. So let's see. So we can take a look at here. And all right. So do we, okay, so we have this, I think this algorithm, let me check. I think what this does is it gets so it lists the test file, right? Yeah, so it lists, so it won't get the output files if they're not, if the input is not existent. you'll see what I mean right now. So I get the split script. Let me see if I do here dataset and I put this here. So I'm gonna get the outputs and the inputs and put them here. So let's say outputs is gonna be called A, and this is gonna call B, and we're going to split the data set. 0 samples. Okay, maybe it's because these are JPEGs. All right, so let's look at let's see if this works. Yeah, but these are the original images, so we should have them all in here. Okay, let's see. Oh yeah, JPEGs are not there. Okay, so if we have JPEGs, target to input to path, target from path, I'll replace AB, and then we can replace also JPEG for PNG. So let's no such file. 371 edges. Okay, so we actually need to remove the edges word as well. So I'm gonna go here with this PNG. Okay, one more try. Cool. All right, let's see if that works. And 1 second. Be back. Okay, let's see where we're at. So what I was saying is we have this PSP dataset now that has been split into test and train, and if we see the third and second images here match with the third and second images here, it's not perfect. I mean, I don't think this is like super high quality in dataset. We could probably get a sample set and make it on our own, but we'll see. I mean, some of these are bad for getting them generated automatically. Yeah, I think there is some information there that might make it work. Okay, so we could train pix to pix with this. We could train StyleGAN, and we could train PSP. So we have the first data set here. Okay, so let's call this PSP dataset. This is to simplified sketches. Okay, so what do we need to do now? We need to open opened. I wanted to try to see the difference between Sobel 1 and Blur 1 and different parameter settings, just out of curiosity to see how that changed. So I'm gonna rerun this thing, and we'll get the same error. We'll get the same images not work, but that's okay. I don't think it affects us a lot. So this is going to do now the same zip file that we have here, but with Sobel 3 and Blur 3. That's a parameter that I am added into this script, into the generate sketch data script, so we can generate different variations quickly. And okay, so let me see. Great, so that's downloading. Now we are going to have to retrain StyleGAN, so I'm going to set that, even though that's going to take ages and we're not going to be able to get anything right now. So maybe I can do a big pause and then come back later, or come back tomorrow morning. And yeah, I want to try to train PSP, even if it's with the older data set, just to see how that works. Well, we do have a like a StyleGAN model. We could train with that and leave the other optimization, like creating a new StyleGAN dataset with this StyleGAN model. So let me write that down. So next steps, train a StyleGAN model only with hand-picked daisies. Then train PSP with that StyleGAN model and simplify sketches to photo. Okay, yeah, so right now we're going to, okay, let's take a look at this one. Let's take a look at the second export that we've done. This one actually might be better. So it might, yeah, it might be, was worth a try, because I think this, yeah, this is so much better. And these are the parameters that the original data set had. So we probably want to use this one instead of the other. So this is a data set, Sobel 1, Blur 1. The other one is the same, but with 3. Okay. And yeah, so we're going to use that one. So this is not on Dropbox at the moment. Let's just make sure that we don't get too many things So this is faster. We're just gonna get the out. Okay, so how did we do this one? So we have to create a dataset folder, dataset. We get these outputs. So that is folder A. So folder B has to be this one, and outputs is gonna be folder A. Okay, and we do Python split. Okay, so we have our PSP dataset, and we're just gonna call it this. And we have everything here. This way we can verify as well that what we did before works. The fork to pixel to style to pixel. Okay, so I'm gonna go to downloads, and I'm gonna put here my dataset. This is gonna now upload to Dropbox. Let's hope that that doesn't slow down the computer too much. And yeah, any other thoughts for whoever is online? I'm gonna open Discord in case there are any messages there while this gets uploaded to Dropbox, even though I don't think this should take that long. Okay, that's already done, even faster than Discord opening. If the computer lags now, if the stream lags, it's probably because I'm trying to open Discord and it doesn't want to open. Yeah, maybe we don't do that. Yeah. Yeah, it was starting to lag on encoding. Okay, let's see if Dropbox is ready. Copy Dropbox link. And that's going to be our new pixel to style to pixel dataset. And we're going to put that right in here. So we'll put a 1. Okay, now we don't need the sketch simplification notebook, so we're going to terminate it. We're going to reconnect here. Let's do a factory reset to start from scratch. And yeah, okay, so we're gonna keep going. So we're gonna do everything that's here. Okay, so I think I'm not sure what Dropbox is doing at the moment, but it definitely lagged the stream a bit. All right, so let's now download the our dataset and see if that gets unzipped properly. That should go into datasets. No, data. Okay, PSP dataset, test photo, test sketch. Awesome. Okay, yeah, we have something. And we verified before that the network that we want to train with was there. So we're gonna set our new, this is live 55, so live 55 there, and users blah 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 blah, you may do so using checkpoint path. And do we want to continue from another checkpoint path? Probably not, because we haven't trained with this data set before. So validation interval, so you guys see it often, we're gonna put it at 300. It's gonna train slower, maybe. Yeah, okay, so let's get started with training. Let's verify we have a GPU. Yes. All right, so this now is going to start training. So we are using the data set that I showed before. Maybe we can also do a montage with this data set. So we have this make file here, and on the data set we have A and B, and inside of this folder we actually have the train images. So maybe we want to go and edit this and say, so this is going to be, for example, test photo and test sketch, and we'll do the same for train. Okay, there are 152 images divided by 20, 18, 15, 14, 15, 12, 8. So here we can specify a tiling. So tiling would be 19 by whatever it needs to be. So we can copy that here, and you'll see that if I make the montage again, these images are going to be like landscape and are not going to have any regularities, right? Oh, we have one missing. I'm not sure why. Yep. Okay, so let's compare these two while we get some training on the background. Yeah, I mean, we could definitely do this a lot better by hand, but the idea is that we have a way to automate this, and this is pretty accurate, I would say. Some of these images, it's good. I like it. I mean, imagine if we had to do this with 2000 images. We cannot even think of doing it by hand. This is pretty good. I like it. Okay, so this is our data set, right? So this is a training set that we're going to use to train our PSP encoder. We have a neural network that is a StyleGAN, and this is the test set, which is similar, so it should work if the model learns something. And yeah, so we've done that, and we can probably add that to folder 55 later. The training started, and we are there. So it has to do a few things. So we're already in step 0, and we're gonna start getting checkpoints on Google Drive, which I'm gonna open on the folder that we specified as the experiment folder, this one. And yeah, so let's see if these, okay, so steps are running. Can I go to, okay, let's close things. Okay, so this is the folder that was automatically created, and this is our current experiment. So let's see if we can use this. It seems like the Drive app on Google Chrome is also pretty heavy. Not sure what's going on today. Let's take a look. I'm gonna take a look quickly if there's anything. Okay, so if we go to the logs, we're gonna be seeing images that are saved here to this directory, and the train ones are automatically saved every, well, here apparently every 25 steps by default. So I'm seeing frames are being dropped on the live stream, and this is because it seems like this interface is super heavy. Okay, so let's see what goes on here. All right, so when we use this is too noisy. I mean, this is really weird. We're getting the average image on the right? So this is the training process. And if we open others, this image starts getting slightly modified by the image on the left. Not sure how or why. And as we go training, it will start being modified more and more and more. But right now we don't see anything, so we're gonna have to give this a few more minutes to see something meaningful. Maybe when we're in like step 1000 or 2000 or something like that. And every 300 steps will validate, which means that we'll run the test images through the model as however it is at that time, and we'll get a set of images, basically predictions inside of the test folder. In here it says faces, but it's actually not faces because we're not using the faces dataset, but it was mainly face tasks like face frontalization, sketch to face, sketch to celebrity, and things like this that the creators of this project run through this algorithm. So that's why everything says faces. So yeah, we'll have to wait a bit, and this is here. So I'm gonna take another break. I'm gonna let this train here. So I'm gonna let this go, and let me see. Let's try this. So yeah, if you are online right now, Merry Christmas. If not, Merry Christmas also. And I would love to hear from you if you're connected now, where you're connecting from, and if you learn anything today, or if you're looking to learn anything on this live stream. I think I'm gonna have to do some work with PSP offline, so I get some. I figure some things out offline. I look for time now, and that we're gonna be catching up with oh we're gonna be catching up, hopefully. Let me actually configure this camera a bit better. Okay, that's better. And yeah, so this keeps training here. So I would love to hear. So no, you have been using an imagery in the PSP project. What do you mean with metrics? You mean like actually seeing the loss, or seeing the Ricardo? So let me get back to programming mode. So I only have a few experiments that didn't work so far. And inside of the logs directory, you can see this man. It's surprising how many resources this Google Drive web tab seems to require to be able to run. Okay, I'm taking off my camera until the stream stabilizes a bit, but I'm still here. So I do have this tensor board thing. Yes, it does. Let's take a look. Okay, so yeah, this is what it's doing right now. So not sure if I can run TensorBoard from here directly. Okay. Let's see. I mean, I'm not sure what this will do here. Maybe we're able to. Yeah, how do I access this? All right. What does this mean? Hmm. Oh, okay. Yeah. Oh, yeah. Okay. So we would need a. So maybe we cannot do it while this is running. Maybe it's only possible to see the metrics TensorFlow if trained locally. I mean, I have the metrics on this algorithm are being saved to. And sorry, so this seems like we're losing frames. I'm not sure. I'm not sure what's going on. Mm, maybe too many things open. Okay, so let's just try to see if we. Oh, okay. Seems like we just need to do this, but we'll have to bind this. Mm. Okay, so if we don't use a GPU, we can use multiple. We can use multiple notebooks even with Google Colab Pro. So you just cannot run high GPUs or light GPUs. All right, so let's see where we are at here. So okay, TensorFlow can be used there to with notebook experiences just Colab and Jupyter. This can be helpful for sharing results, integrating TensorBoard into existing workflow, and using TensorFlow without installing anything locally. Start by installing TF2 and loading the TensorBoard notebook extension. For Jupyter uses, if you've installed Jupyter and TensorBoard in the same virtual environment, then you should be good to go. If you're using a more complicated setup like a global Jupyter installation or kernels, blah, blah, blah. Okay, let's first try just this. Let's see what happens. Okay, great. So we have TensorFlow in here. So TensorBoard, and we have our metrics, but we're seeing okay. So the loss, train loss, so loss keeps going down. Loss over norm goes up. Loss ellipse goes down. Okay, I mean these are good metrics for us to follow. I need to see what each of them means more specifically, but I guess we can open Google Drive now to see the things that we've trained so far, which we are at step 450. Let's see. Let me see. All right. So let's see. Yeah, that's what I thought, right? Like the model seems to be learning. I think this is better than before, but the thing is that they mentioned on the paper that maybe it takes 300,000 steps to learn in like 2 or 3 days. The good thing is that there is an easy way, as we saw before, to use a previous checkpoint, so we could train, and then if it doesn't finish, we could continue training afterwards. But yeah, let's try to see if this opens again. Like I don't understand why Google Drive, the application, the web app is super slow here, and it's actually clogging my machine. See how long it takes. Okay, I'm gonna close this because it's making. I have another. Let me let me get another computer really quickly. Okay, I'm back. Yes, I mean I'm seeing the images here, but these, as I've used this model before, it's gonna take a few couple thousand probably steps for something meaningful to show up. So I don't know. Maybe I just do a few training runs of my own and then we check back on it. I'm gonna try to see if I can continue monitoring on a different machine, because with at least with Google Colab, I can close this session. Well, I can save the changes and then close this session, and I should be able to connect from another machine. Okay, let's leave. And yeah, I can see on the other machine, I can see the the info. So this is, let's see if we can reload inactive. Let's reload here. We can reload. Seriously, this is going slow. And today is not my battery. All right. Yes, I think, I mean, this is another experiment. Let's see if we can make it work. Let me see. Okay, so okay. Okay, let's see. Okay. I've had more I've had smoother live streams. Anyhow, anything else? So Ricardo, I think you're right. Like the metrics are there, and we need to take a look. I looked at that TensorBoard log the other day, but the model wasn't just. I mean, it wasn't learning properly. I can show you. I don't know what's going on. Seriously. Okay, let me try this. This is just a test. Okay, so I have the yeah. It seems like this camera mode is not being liked a lot by OBS today, and it might be because I changed the resolution, so I put more resolution, so I might be choppy. I probably are. So let me see if I can change it. Hmm. I'm really not sure if the camera quality is going down or not. Okay, I think this is dying. Anyhow, this might be the reason why. This might be the reason why the live stream is slowing down today. Might be. I'm not sure. So this is the these are the frames that are dropped, and if I do this right, is this slow? I don't know. Yeah, this is slowing down. So encoding is slower. Hmm. This doesn't work. All right, let me go. I'll try to figure it out. I'll try to see what's going wrong, and we'll try to we'll try to get back at you. Rendering lag, And you know, in this mode where I'm here and I'm smaller, it doesn't seem to happen. But when I go big, it does. And I did definitely touch some settings on the camera, so that might be one of the reasons why this is happening. When you use the computer screen background, there is zero lag. Yeah, that's the thing that I was able the other day to use this version, and right now, you know, if I move fast and this tries to encode video with the background and things like this, I think it does. It's random because it doesn't happen all the time, right? Like it's not happening now, definitely. Oh, it's starting to happen now a bit. Not sure. Maybe I need a restart of my computer. Maybe that's it. But yeah, we're going again, losing frames. Okay. Good that it works this way because it's the important part. So there seem to be some encoding lag there, here and there. And I can also move here and the same thing should happen, right? Like it shouldn't affect the. Okay. Yeah, I'm still figuring this out. I'm taking a look at whether OBS provides support for M1 chips and I can upgrade. Anyhow, I'll check on that on my own. Okay. Um Good. So Ricardo, thanks for joining us. Maybe we can join forces and get some of these data sets working. It just takes a long time to train, so that makes it hard for me to debug. Let me take a look at this other machine, at where we're at. Um, what step and BC? Okay, step 750. So we had another checkpoint at 600. Yeah, and I'm seeing something similar to what I was seeing the other day. So the model is definitely still not learning a lot. Let me, maybe I can send the images to show what I mean. Oh, also I had my, okay, let's make another test in a second. Okay. Hmm. So what I was saying is that I had the OBS preview on. So if I, let's try this out. So if I do this, is this also gonna give me lag? So if I do this, hello, hello. Yeah, it definitely lags when encoding this way. Oh, a lot. Okay, yeah, let's try it later. And yeah, everything's failing here today. Okay, I think it's time to call it a day today. I want to show that. I'm not sure if I can. Okay, so this is the folder. So even if it lags, forgive me. I think that's fine. We'll know what's happening. Man, this is low. Okay, I'll hide myself just in case this goes a bit slower or a bit faster. So okay. This is not bad. I mean, well, this looks really similar to the original, so I'm not sure. This is with a training set, so this is not the test set. Yeah, still pretty far. Let's see the test so you see. Yeah, the test set is still really far away. Yeah, it does these weird artifacts that I've seen before with other models. So maybe it does need many steps to train. So I guess I'll have to try and train this for 300,000 steps and see what it does. All right. Hopefully now, yeah, now it seems you can see me properly. So thanks a lot for being there. Thanks Mayur, thanks Rob, thanks Sajed, thanks Bea, thanks Alvaro, thanks Ricardo, thanks everyone. Merry Christmas. I hope you can enjoy remotely or in person with your close ones. And yeah, it's been a pleasure to do this first part of the second season of the live stream. I hope to do one more live stream before the end of the year, more podcasting probably as well. We have an interview with Jordan Gray that we are editing now, so it has a video and an audio and go on the podcast. It's going to be a long form, around 2 hours, I think, probably a bit less. And yeah, thanks so much for being there. Thanks for watching. We'll see you next time. Let me find my way. Okay, so this is something that hasn't happened. Okay, so I can actually stop the stream from different computer. So 1 second, everyone. Yeah, remember to like the video to support the channel if that's not too much of an ask. And yeah, I'll see you next time. Thanks a lot for watching. Bye bye.